At the heart of our solar system lies an extraordinary force. The giant ball of plasma, burning at millions of degrees, radiating energy that sustains life on Earth. But how much do we really know about the sun? How was it born? And what keeps it shining? And what are those violent flares and mysterious dark spots on its surface? Today, we're uncovering the secrets of our closest star, the Sun. The story of the Sun begins 4.6 billion years ago in a dense molecular cloud. Gravity, the cosmic sculptor, pulled together gas and dust, compressing it into a hot, spinning core. As pressure and temperature soared, nuclear fusion ignited, and a star was born. A star that would light up an entire solar system. This wasn't a peaceful birth. The Sun's early years were chaotic. Intense winds and radiation cleared away the surrounding debris, shaping the orbits of planets, including our own Earth. This fiery beginning set the stage for everything we see in the solar system today. In the vastness of the Milky Way, it's just one among hundreds of billions of stars. Average in size, but extraordinary in importance. The Sun dominates the solar system, holding 99.86% of its total mass. The Sun is a complex giant with distinct layers. At its core, temperatures reach 15 million degrees Celsius. In the radiative zone, energy takes thousands of years to move outward. In the convective zone, heat rises like boiling water, driving the Sun's dynamic surface activity. The photosphere is what we see, a glowing surface radiating light and heat. And beyond it, the corona, a superheated outer layer, hotter than the surface itself. Each layer contributes to the Sun's behavior, influencing everything from solar flares to the gentle warmth we feel on Earth. Now imagine this. A sudden burst of energy erupts from the Sun, releasing as much power as billions of atomic bombs in seconds. These are solar flares, one of the Sun's most dramatic phenomena. But what triggers them? And how do they affect us here on Earth? What happens when they collide with our planet's magnetic field? Could they one day cause catastrophic damage to our technology, or are we prepared for their impact? These flares don't just stay in space. They can disrupt satellites, knock out power grids, and even endanger astronauts. What's driving these explosive events? Is there a way to predict them? And how do they shape the boundary between Earth and space? Their influence stretches from the fiery core of the Sun to the amazing auroras we see on Earth. But what is their full impact? We're only beginning to understand.
Solar flares are giant explosions on the Sun that send energy, light, and high-speed particles into space. When strong enough, flares can affect communications and navigation systems on Earth. There were 9 X-class flares between May 3 to 9, 2024. which is over 50% of all X-class flares in 2024 to date. During this period, the most intense flare occurred on May 6. This is how it looked like. X-class flares are the most intense on the flare classification system. These solar flares came from two large sunspots groups, one of them big enough to see from Earth without magnification.
Have you ever noticed dark spots on images of the sun? These are sunspots, temporary regions of intense magnetic activity that are cooler than their surroundings. They're like cosmic weather patterns, often signaling increased solar activity. The sun also emits a steady flow of charged particles called the solar winds. They can disturb communication systems and even affect technology on Earth. When this wind interacts with Earth's magnetic field, it creates spectacular light shows near the poles. Auroras. Sunspots and solar winds are just glimpses of the sun's powerful influence on our planet. Understanding them brings us closer to unlocking the mysteries of this cosmic giant. The sun is a reminder of how interconnected we are with the cosmos. It's not just a star. It's the key to life as we know it. Without its light and heat, our planet would be a frozen, lifeless world. In 5 billion years, the sun will expand into a red giant, eventually becoming a white dwarf, a quiet end to a brilliant star. Subscribe to The Final Frontier for more journeys into space and beyond.